One lecture, we are going to learn that how we practically implement one geometric transformation of images. That one is rotation, means how we'll practically implement the rotation of images in OpenCV using Python. Now, basically the concept involved here is that rotation. Rotation is what? Rotation of an image for an angle is achieved by the transformation matrix of the form cos theta sin theta minus sin theta cos theta. Obviously, when rotation will be carried out, we need what? An angle, like how much angle we are rotating the image. That may be 90 degree, that may be 180 degree, whatever it is, right? And this particular transformation will be done through this matrix. Remember, cos theta sin theta minus sin theta cos theta. But OpenCV provides scaled rotation with adjustable center of rotation so that we can rotate at any location we prefer. Hence, if we consider the modified transformation matrix, right, that will look like this one. And here, you better take as means consideration. If you are going to write this detail, then you have to take a screenshot of this. And the concept is very easy because the values a and this particular means sorry, alpha and beta, these values we are considering scale cos theta and scale sin theta respectively. Now, although it seems a kind of difficult, but it is actually very simple. You just remember this equation, and there you put this values of alpha and beta. Now, to find this particular transformation matrix, which looks complex, I know, I understand, but in OpenCV, you can easily do it with a function that is CV dot get rotation matrix 2D. Right? So this function you have to remember, CB get rotation matrix 2D. Now, how we can do this, or how we can use this particular function for the rotation by 90 degree, I'm going to show in this particular practical. So please take a screenshot of this. You can see that import CV2 as CV. This is the image location. I am considering linear image. Original image I am showing with this CV.imso, means CV, we are importing CV2 as CV, right? So we are showing this image first with the imso function, then wait key 0, so that if we click the close button, that image will be closed. Now, if it is not found, this message. Now we are converting this color image into gray version with this CV dot color bgr underscore bgr to gray function, and which you as use as a parameter for the function cvt color. So image 1 equal to cv.cvt color, this particular original image, comma cv color bgr to gray, right? Then we saw the grayscale version, same thing, CV weight key 0, grayscale version is the image 1. Then we consider the shape of this image 1, and we are putting this value in rows and columns respectively with this particular line of code. Now, cols minus 1 and rows minus 1 are the coordination limit if we consider from 0, right? So CB get rotation matrix 2D, the values will be cols minus 1, divided by 2.0, rows minus 1, divided by 2.0, 90 and 1. So we are trying to rotate the image by the angle 90 degree. Then DST, CV, WAP, affine, image, dot M calls rows. So ultimately, so this rotated version, which is stored in the DST value, rotated done. And then you can put any message like rotation done or like that. Then CV weight key 0 for closing that particular close button, and then destroy all window for the memory release. So I show you each and every line of code. Let's implement it in the OpenCV. For that, I'm using Spider. Let's open the Spider. So you see, I have written the code that I've shown you just here, and everything you got it, each and every line of this code. Okay, now let's just run this function. So this is the original image. Well, you got it, the original image. Then close it. Then what will be shown? the gray version, this particular code. You can see the my mouse cursor, right? So grayscale version, this is the grayscale version. See, this is the grayscale written here. Then close it, then what will be shown? This is the rotation image by 90°. Okay. So 90° rotation means what? In this way. So this is rotated. The original image is rotated by 90°. Well, I hope now it is clear to you. So you can perform any rotation by specifying the angle by which you want to rotate. And you can specify here the values exactly in this particular lines of code. So, well, guys, I hope you have enjoyed this session. Please don't skip the practical. Do it right now. Okay, I'm watching you. Well, let's meet in the next class. Till then, take care. Bye-bye.